Hello everyone, I'm Shruti here. Actually, recently I had enrolled for a course on machine learning from Skyfi Labs, and they had given me an assignment, like a project on ML, that is machine learning. I had to create it and upload a video on YouTube. So this is my first ever video on YouTube regarding this. And to describe about the machine learning, it was really helpful course for me. I could learn the basics of machine learning and then what is machine learning, the various types of machine learning, and they even explain how can you create your own project on linear regression. So basically, it was overall an helpful course, a very informative course. And the best part about the course was the videos were pretty short, sweet, up to the mark, up to the point. I mean, whatever they wanted to convey, they conveyed it very beautifully in simple words and terms. And also, the best part was that they had divided the module topic wise. So based on, like, suppose you complete one module, then you have to give a MCQ test, after which the other module will be unlocked. So, because of that MCQ test, you will research a lot. I mean, it's surely that you can't answer all the questions, but when you do, you'll even research about the topic much more other than what is given. So, in all, it was really great course. I really encourage all of you listening over here to enroll on Skyfi Labs. Even I'll try myself for enrolling such future courses. So here I am with my project. So my project is basically a classification problem, a simple classification technique that I used on a data set called as food data with colors. I got it from the Kaggle website. It's a very short and sweet, simple data set that I've used because this is my first machine learning project. So I thought of going out with slow. Yeah. So, as you can see, I've imported certain libraries over here. There's NumPy. This NumPy you can treat it like an array, and this matplotlib is used for displaying all that kind of graphs, the animation effect. Graphs is like the bar graphs, scatter plot, or the histogram, anything that sort. And the pandas is kind of a data frame. The data frame you could tell it like something like a database. It's kind of same, it's representing the same. So here I have that, and sklearn. This sklearn, it has a n number of libraries to import. Over here I have imported train and test split. I'll explain it in the further project. So here this fruits.head would give me the first 10 rows of my head column. So as you can see, my data set will consist of a fruit label which has 1 and 2 as fruit labels. The fruit name being the apple and the mandarin, and the fruit type like which kind of apple or which kind of mandarin it is, along with some parameters such as mass, width, height, color scope. So basically in this my output would be this label, that is 1 and 2, and my parameters or features would be this mass, width and height scope, color scope. So as we go down further, we can see that this is basically, I took a dictionary kind of thing and zipped it along with this table, the fruit label and the fruit name. That is, unique keyword is used for finding out what are the unique elements in the particular column. So what here I get is 1 is equivalent to apple, 2 to mandarin, 3 to orange, and 4 to lemon. So these are my output labels, as you can see, along with the names. In my case, I won't use the names as such. I will use directly the labels. So we need to remember that 1 is for apple, 2 is for mandarin, 3 is for orange, and 4 is for lemon. So coming here to examining the data, as you can see over here that on executing this command, I'll get a graph somewhat like this. This is a resemblance to of a heat map, you can say, where the diagonal elements will give me the bar graph and the rest will give me scatter plot. So I will show you the code. Yeah. So to see that the X label, that is the feature of the data set, as I mentioned earlier, that is height, width, mass, and color score. And the Y would be the label, that is the fruit label, as I said. So what will you do with the data set available? You can't entirely use it for testing purpose or for training purpose. So the library that I used earlier from sklearn, that was the import uh, train test split. So that would do a splitting of the entire data set randomly. It won't, do that first and last and nothing like that. It would randomly select the fields of the data set, and it will store 75% of the data set to the training split and 25% to the test split. So it automatically splits the data set over there. So you will get a train and test data. So as you can see over here, all my features are shown in extreme. My features, my labels are shown in XTest. My Okay, my bad. I just misinterpreted. Yeah, the train features, the features that are used for the training set are stored in Xtrain. The features used for the testing purpose is stored in Xtest. The the label, it is stored in the for the training is stored in Y-train, and the label used to store in the test is stored in the Y-test. I'm sorry, if I'm fumbling. Yeah. So over here you can see that I created a scatter plot for the others and a C map, that is like a heat map for overall. Yeah. This actually is used only on the extreme, as you can see in Y train. I mean, basically it is used for the features, that is the height, width, mass, and color. So you can see that's a direct relation if it is height, and if it is height from here. Close this. Yeah. If it is height and height, if it is width and width, I'll show you for color and color. You can see. Yeah. In color score and color score, you'll get a histogram over here. And then, yeah, it's a histogram bar. Yeah. So the next is, so as you can see over here that in this case a 3D model of scatter plot is developed only between the height, width, and color score. These are the features, as you know. So this scatter plot actually helps you to understand the relationship that the width has with the height, the color score, the height has with the width color score, and color score that has with height and width. Actually, the previous graph was also used for understanding the relation, how they are correlated with each other basically. So this is in case of a 3D plot, you can say. I just, yeah, that is X, Y, and Z axis is it as used. Yeah. So now this is, see, I have written over here the default is 75 and 25 for the train and test data. That is the whatever data set you have, 75% randomly it will be stored in the training. The model will get trained using that data set, and then it will, train the model to get a results, and after which you can give the test data set to just check if the answers that have been given are correctly. Basically, classification problem is what you give an input and you classify it as say positive or negative. Like you give a sentence and you can just comment on if it is a positive sentence or a negative sentence based on the words. So this is what classification problem is. So using the training and test, we'll do the same. Training is used for, training the entire model that we are using, and testing is we can give such parameters such as features into it. We just test whether whatever values we have given is it resembling the same thing that we wanted, the output that we wanted. So I just, yeah, we'll just run this. It's done. Mm. Okay, so in my model of classification, I have used KNN, that is the key nearest classifier. This classifier is basically it's basically like you have a point. Suppose you want to predict. So a point, you can call that a test point. So that test point will be compared with other points around its surrounding, the closest other points in the surrounding of the training set. The training set will already be in the graph. We'll just compare the test point with the other surrounding points in the graph. In my case, the surrounding points are five. As you can see, I've taken five neighbors. It could be even one, it could be two, it could be five, it could be 100 as well. As the number of neighbors it increases, the more amount of accuracy you'll get, and you'll understand the splitting range properly. I mean, in this case, we have four splitting range, that is the lemon, orange, apple, and Mediterranean. So the four splitting ranges can be clearly explained as and when we increase the number of neighbors. So here I have taken five. Okay. So I just run the KNN classifier that I imported from sklearn. Over here, this KNN.fit, it is used to best match the curvature of the given data points. You might have been given two data points, and you might be asked to derive the equation of the line passing through the 2 points. In the high school, I mean, any one time high school, sometime you might have done that. Like you might be given 2 points, and you have to find out the equation of the line, that is like y is equal to mx plus c. So you have derived a fitting function. So that is exactly a fit function over here it is used for. So we'll just I mean, we'll use the fit function for the x train and the y train. So as you can see, using the sklearn, we imported the KNN library. We defined the number of neighbors that we want. We fitted it so that you can get the best accuracy of the curvature of the points. After which our training is done. Our training of for classification using the KNN model is completely done. So now we'll just test the accuracy of our training model, and that with accuracy will be done using the test data set, that is the x test and y test. We'll give it to the function called a score that will determine the accuracy. And when I just enter here, you can see it is 0.533. It is because you really have a less number of neighbors, so the splitting range is not defined properly, so that the test function is not set properly. Now I'll just change the neighbors to say 50. I'll just run this. Just fit again. And I'll just test the accuracy over here. I need some error. The other issue is that okay, I misspelled something. I'll just change this and I'll do it again. And still the same. Okay. The sample it has 44. Mm, I'll change it to say 40. Run this. I hope it will work this time. Yeah, it does work. So since I have used the maximum, I mean like there are only 44 samples in my data set, out of which I use 40. So the accuracy scores, it just goes down. You have to see this actually shows how the graph of the test and train data set would be. So I'll just keep my maximum accuracy that I got from 5 and run it. Actually, you know what? You need to find that one point at which you'll get an accuracy more than 0.5. You know, if 5 neighbors, I got it this way. Suppose I can take 10 neighbors and I can see there definitely might be some variation with the rather than 10, I'll take 15 and I'll just try. There will be a slight increase or a slight decrease in this. It's now 0.532. Let's just 6.26. It's because of these samples. Okay, now here I'll just directly give the function predict in which I pass the parameters, that is height, width and the color range. So over here I've given the first fruit and just pass it on. It's a lemon. If you see the data set, you can compare the results of a lemon. I mean, mostly the weight is this lemon. Okay, and this we don't have lemon. Just this fruits. Can you compare lemon? Hmm. When you see the lemon, mostly you can see the height is in your first parameter is height, then width, sorry, mass, then width. If you see the mostly whatever mass of the lemon it is in our data set, it's above like 150. It's in the range of 100 to 1, and there is 200 as well to 160 also. Average weight could be 130. But in our case, yeah, we had only a mass of 20 grams. So this is this is not a, I mean, this wasn't in the test set, because of which it wrongly predicted it. Now let's see of this, what it gives. It gives a lemon. This is a correct prediction because you can see from the data set that the average is about 100 to 150, the mass and even the height and the width if you check. So as I mentioned earlier that the graph that could determine the splitting range is over here, that I plotted using the 5 nearest neighbors. So suppose I have a point over here, then the 5 nearest neighbors of it would be 1, 2, 3, 4 and 5. These are calculated using the mean distances, and that point would be in this red range that becomes an apple. So this is the way that we calculate. Since you increase the number of points, I mean the number of neighbors, the point might be misspelled or the accuracy might decrease because of these reasons itself. So this is my entire project on classification of this data set, food data set that I got from Kaggle. This is my first ever YouTube, so I'm really sorry if I fumbled or I just stopped in between because I really got nervous